and welcome to my presentation, Raspberry Pi Sky. My name is Allison Lujan. I'm currently a senior at Valencia College in the Computing Technology and Software Development Bachelor's Program. I'm set to graduate at the end of this semester in the beginning of August 2024. Raspberry Pi Sky is a time-lapse video that I created using a Raspberry Pi 4 Model B. The Raspberry Pi is a single-board computer, or SBC, that is about the size of a credit card. Using Python, I was able to program an SD card to insert into the Raspberry Pi, which instructed it to take pictures at a specific interval in order to create a time-lapse. The other pieces of hardware that I used were the Raspberry Pi high-quality camera, a Raspberry Pi power supply cord, a micro SD card, a 6mm 3MP lens for Raspberry Pi HQ camera, and a micro HDMI to HDMI cable adapter. I had also purchased a camera mount for my Raspberry Pi, but I did not end up using that. To program the SD card and create the time-lapse, I used two types of software: the Raspberry Pi operating system with Raspberry Pi Imager and Visual Studio Code. On the right here, you can see my setup with my Raspberry Pi and the camera, and how I took my time-lapse pictures. Here is a small sample of the pictures that I collected. Overall, I took about 860 pictures. As I mentioned earlier, I used the Raspberry Pi operating system with Raspberry Pi Imager. Raspberry Pi OS is the official operating system for Raspberry Pi. Raspberry Pi Imager is a tool that was created to simplify the process of installing an operating system onto an SD card for use with the Raspberry Pi. I also used my command prompt to program my SD card and connect it to my local Wi-Fi. And I used Visual Studio Code to put my pictures together and ultimately create my time-lapse. This was a personal choice and not what I originally intended to do. On the left is a picture of the Raspberry Pi 4 Model B. When I originally planned on doing a time-lapse, I intended to take pictures to represent an entire day. When I did my initial research, it was suggested to take pictures every 3 to 5 seconds for the best time-lapse, and after doing the math, I realized that an entire day would create too many pictures, which would create too long of a time-lapse for a short presentation. When I realized this, I changed my idea to capturing only a shorter span of time, and then eventually decided to capture the sunset. I also originally planned to put my pictures together using a separate external video player, but when I had difficulty with this, I pivoted to using Visual Studio Code to combine my pictures. Here's a brief explanation of the steps I took to complete this project. First, I had to gather all my hardware, which was mostly ordered from Adafruit.com. I did order an SD card and the HDMI adapter cord from Amazon. Next, I had to download and install the software that I needed for this project. I installed Raspberry Pi OS with Raspberry Pi Imager to my computer, and when that was done, I had to write the image to the SD card. To the right here is my SD card, my HDMI adapter, and the interface for the Raspberry Pi Imager, which helped me write the operating system onto my SD card. The next step was to connect all my hardware. As you can see in the picture here, I put my lens onto the Raspberry Pi HQ camera and attached that to my Raspberry Pi. I have my SD card inserted on the bottom side of this Raspberry Pi here in the picture, and then I have the power cord and the HDMI cord plugged in. Once I knew everything was working properly, it was time to install the software that I needed and start creating the program for the Raspberry Pi. So the first step for that was to update my system and install the camera software by using the commands pictured here. When that was complete, I wrote the program for the time-lapse, which is shown here. Overall, this is a very simple program, and it can be altered to take pictures at a different interval or a different resolution, and as many pictures as you want, which is the frames. Once I had captured all my pictures, I had to get them into video format. First, I took the SD card from my Raspberry Pi and inserted it back into my computer, and I uploaded all my pictures into a folder onto my computer. I decided I would use Visual Studio Code and Python to combine the pictures, so I had to download Python to my computer and the Python extension in Visual Studio Code, as I've never used Python before. Here is the code that I used to create the time-lapse video from the series of images that I stored in my folder. This code imports the necessary libraries and then defines a function called createTimelapse that takes an image folder, an output video file name, and frames per second as parameters. The function reads all the images in the folder, sorts them, and then uses OpenCV's video writer to compile these images into a video at the specified frames per second. Finally, it writes the frames to the output video file and releases the video writer object. On the following slide is my time lapse. I scheduled my Raspberry Pi to take a photo every 5 seconds for about 1 hour and 11 minutes, and this resulted in a little over 860 pictures. I programmed my time lapse to be 20 pictures per second, which results in the following 42-second video. Throughout this project, I did face a few technical challenges. The overall challenge was learning and using the Raspberry Pi, which was a completely new system for me. I was able to learn a lot about the Raspberry Pi through YouTube videos and online articles. After I figured out the basics, I had two specific technical challenges. The first was when I initially programmed my SD card and inserted it into the Raspberry Pi would turn on and then would turn off in about 15 seconds. I realized after researching that this was because of power issues and that I needed to have a power cord that had the appropriate voltage to support the Raspberry Pi and the HQ camera. The second issue I had was that I couldn't take pictures on my first try when I set everything up. You could see light through the pictures, but there was no image, and I realized that I needed an additional lens for my HQ camera because the HQ camera itself is photosensitive and cannot be used on its own. I had mostly successes during my project, but I did have one main disappointment, which was the quality of my pictures. My pictures aren't horrible, but they aren't the quality that I expected when I purchased the high quality camera with an additional lens instead of the Raspberry Pi basic camera that was available. Besides that, I am very pleased with how my project turned out this semester and that I was successful in using the Raspberry Pi and also using Visual Studio Code to create my time lapse. If I were to do this project over again, knowing what I know now, I would change a couple of things. First, I would have spent more time taking pictures on multiple days in order to capture the best time lapse. I would have done multiple sunrises and sunsets, but because I was trying to stay on track with the project schedule, I only took pictures of the sunset once, which is my final result. The sunset that I did capture was pretty, but not as breathtaking as I think sunsets can be. I also would have found a spot that was more open and did not have the sky blocked by anything like the houses or the tree in my video. To the right here, I included a picture that I took of the sunset from my phone in November of last year. This is an example of what I would like my project to look like if I were to do it over again. But the issue with this is that this picture was taken outside in a fieldy area, and to do my project I needed to have a reliable power source as well as keep my hardware safe from the elements outside. Overall, I enjoyed working on this project. It allowed me to push my boundaries in working independently, and I learned about a new system in the process. I plan on keeping my Raspberry Pi and using it for personal projects of mine. Although there may be a couple things that I would have changed, and I did have a disappointment, I'm proud of my result and my ability to push through the challenges that I faced. I appreciate your time and attention, and I hope you enjoyed Raspberry Pi Sky.